Hello and welcome to our presentation on the forgeries of Frank William Abagnale Jr. Frank was born in Bronxville, New York, April 27, 1948, and is best known for his younger years where he lived a life of a con man. In this time, he'd taken on at least 8 different identities, which include an airline pilot, a physician, an attorney, and a teaching assistant at a university. He also committed numerous bank fraud cases using these identities. He was eventually caught and arrested in 1969 in Montpellier, France. He was sentenced to 6 months in Perpignan prison after a flight attendee that he'd slept with recognised him and notified the French authorities. On top of this, 12 other countries sought his extradition, of which Sweden achieved, and he was sent to Sweden after his sentence was up in France. He was given another 6-month sentence in Malmo prison, which he served and then was supposed to be extradited again to Italy, but Swedish officials contacted the US and had his passport cancelled, leading to his forced return to the US, where he was handed a 12-year sentence, and he served less than 7 years of this sentence. Now he is 72 and the owner of a secure document consulting company called Abagnale and Associates, where he teaches banks and other companies on how people may go about fooling them. His main employer are the FBI, who he has taught over 10,000 lectures to on fraud detection. Frank's first scheme came around when he was just 16. He would open accounts with different banks and write personal checks on overdrawn accounts with multiple identities. Another scheme was to use blank deposit slips with a magnetically printed account number on and put them in with real ones, leading to other people's deposits being transferred into his accounts. His second fell between the ages of 16 to 18, where he scammed an airline called Pan America World Airways by calling and informing he had lost his pilot uniform at a hotel and gave a fake employee ID number, so they sent him a new uniform. He then forged a Federal Aviation Administration's license. This enabled him to travel over 1 million miles, estimated to be about 250 flights, and visiting 26 countries, entirely free of charge, with it all being billed to the airline. His third case came in Georgia after a near capture in New Orleans, where he posed as a doctor. When in Georgia, he filled out a rental application, impulsively registering his occupation as a doctor, afraid of using the airline after the near capture. He assumed a new identity of Frank Williams, becoming a physician under fake credentials. He was almost discovered on a night shift when the nurse informed him they had a blue baby. He misread the significance, and after a close encounter, he resigned the next day and moved on. He moved on to Louisiana and forged a Harvard law transcript to take the Louisiana bar exam. The Louisiana bar exam could be taken multiple times. He actually failed twice and then passed on the third. This gave him access to a job at the Louisiana State Attorney General's office. He described his job as a gopher boy, where all he really did was grab coffee and books for his boss. He came across another Harvard law graduate who worked under the same employer, who convinced the employer to run a background check after he became suspicious of Frank, which forced him to move on and resign. For paper techniques, we will use VSC, which stands for Video Spectral Comparator. There are multiple ways that you can use VSC, such as visible light, which looks for watermarks, microscopy, which looks for microprint, UV light, which assesses optical brightness, light angle, which assesses patterns only visible at specific light angles, and a pass filter, which can identify thread. These techniques can be used on documents such as Frank's checks and academic certificates for validity. We can also use Pulp Analysis, which uses infrared radiation, which can give us a chemical composition of the paper, which can be linked to Frank's checks. This is also useful for identifying the check supplier. For ink techniques, we will use TLC, which stands for Thin Layer Chromatography, which is a non-destructive technique, UV-Vis, which is a destructive technique, and HPLC, which is High Performance Liquid Chromatography, which is also a destructive technique. These will allow us to identify components within dyes, which is useful for identifying different types of pen, whether it's ballpoint or fountain, which is useful to identify what Frank could have used to materialize his fake cheques and transcripts.
Paper analysis. Determining the origin of forged cheques by analysing the paper they were printed on. Let's start with the basics. Abagnale used three types of cheque during his forgery career: personal, payroll and banker's cheques. Here is an example personal and bank cheque. Luckily, although very different in style, origin and issue, they all share common qualities. They're all made of paper, a wood pulp composite. The quality of each paper depends largely on the pulping method and cellulose content, with impurities always present. In the bottom left here is an image of low quality paper, mechanically pulped and low cellulose, and to its right the high quality chemically pulped with high cellulose content. One of the first things we can do to identify Abagnale's forgeries is to look closer at them. Using the VSC, we have a variety of options to differentiate between genuine and forged. Bottom left here we've got visible light in the 750 to 400 nanometer wavelength, allowing us to spot watermarks, pictured here on a banknote, but also present on payroll cheques cashed by Frank, issued by Pan Am. Microscopy at 30 times zoom shows us the microprint, here on a $100 bill. UV at 400 to 1 nanometers range, showing optical brightness, absorbed in the UV and admitted in the blue. Next up we have banker's draft security, including patterns only visible by specific light angles. We can do this with a VSC. And running high pass filters allows us to see specific details also hidden from the naked eye, including a paper weave. To examine the microscopic morphological features, we must now move on to destructive analysis, that of the fibres themselves. We do this by tearing the sample into small pieces, weighing around 5 grams, putting them in a beaker with 150 ml capacity, then covered with a 1% sodium hydroxide solution, and heating gently on a hot plate at about 60 degrees for 20 to 30 minutes. After that, allow it to cool, decant the alkaline liquid, and wash the pulp with distilled water 2 or 3 times. Then cover with 5 ml of hydrochloric acid, allow it to stand for 30 minutes, decant and then wash carefully 5 or 6 more times with distilled water. Draining off the water, rolling the piece of pulp into small pellets allows us to complete the rest of the procedure, which in this case is going to be suspending the fibres. We're going to do that by adding 250 ml more of distilled water, graduated cylinder with a suspension 0.2% pulp. So shake that vigorously and the fibres are thoroughly disintegrated. Here we're using the Seliger stain, which is 100 grams of calcium nitrate dissolved in 50 ml water, added to a 3 ml solution of potassium iodide of 8 grams, dissolved in 90 ml of water, and 1 gram of iodine added. Allowed to stand for a week, and the stain is ready to use. Applying a few drops of the stain on the fibres before placing the cover slip on, making sure there are no air bubbles, ready for microscopy. This Seliger stain allows us to clearly identify the flax, hemp, cotton and kozo present. It's worth noting here that bleached softwood would appear purple, unbleached softwood would appear blue, and groundwood in yellow. The pulp sample, dried and unstained, can also be analysed using FTIR, comparing the infrared absorbed against common stock information. This spectra shows 10 paper samples of varying age and quality, and we can see here that not all of these samples come from groundwood. The oxidation of cellulose producing a 1730 wavelength and 1735 for non-conjugated carboxyl groups. Lignin at 1597 confirms this groundwood. The 3 amide bands showing they are indicative of gelatin use. Also clear here are peaks of additives and impuratives, calcium carbonates and sulfates. Now a closer look at the cellulose fingerprint allows us to narrow down further the constituents, with the glycoside bond at 895, carbon oxygen in the alcohol groups of cellulose at its primary 1030 and secondary 1055 stretch positions, double bonded carbon in lignin aromatic bonds at 1510 and 1595 lets us decide between the two. And with this wealth of information we can identify Frank's paper, bringing us another step closer to locating him.
The analysis of ink, determining which pen a forged cheque was written by. First, we're going to take a look at how each ink is different and how to go about distinguishing them. Inks have three major components: colorants, which come as either dyes or pigments; a vehicle, which is a liquid that acts as a solvent to a dye or suspends a pigment; and finally a resin, which binds the colorant to the paper and is the major factor when describing the ink's viscosity. A quick note regarding the two types of colorants: as can be seen in the image of the right, a dye will seep into the top layer of paper and color it, whilst a pigment will not enter the paper and instead sit on the surface. Each of the components in an ink can come from a wide range of sources, such as rosin from conifer trees, seen in the bottom left, or synthetically made resins, seen as the one in the middle. Two different inks may look almost identical to the naked eye, and yet when placed into sensitive machinery of UV-Vis Spectroscopy and HPLC, the differences between them are clear to see. UV-Vis spectroscopy is an analytical technique that looks at the absorption capabilities of a particular compound in the ultraviolet and visible spectral regions. Molecules containing electrons can absorb the energy from these wavelengths of light to excite electrons into higher antibonding orbitals, and the larger the energy difference between these orbitals, the longer the wavelength of light it can absorb. Each molecule has its own configuration of electrons and as such will produce a unique signature in such a machine. The absorption spectrum of crystal violet, a dye often used to stain bacteria, can be seen on the right-hand side. The large peak at 586 nanometers shows us that the dye primarily absorbs light in the yellow to orange area, as well as some absorption in the ultraviolet regions down at 200 nanometers. This is in stark contrast to the pigment known as beta-carotene, seen in the bottom left. Its absorption spectrum shows primarily absorption in the blue areas of the spectrum. Finally, UV-Vis spectroscopy can also be used to tell the age of an ink. As an ink ages, it will become more and more methylated over time, and the more methylated an ink is, the longer the wavelength of light it will absorb. This results in a slow shifting of an absorption spectrum to the red area over time. Thin layer chromatography is a technique used to differentiate between multiple colorants in an ink, but is more suitable to soluble dyes rather than pigments. It being a non-destructive technique allows for a particular ink to be sampled and tested while keeping the initial forged cheque intact as evidence. It primarily involves the use of a thin layer of adsorbent material such as aluminium oxide and relies on the capillary action of liquids to draw the ink up the material and spread the ink out. As this occurs, lighter colorants will be pulled further up the material, and over time the individual colorants will be separated from each other. As can be seen in the picture on the right, different inks show very different patterns post-chromatography and allows quick and easy distinguishing of two dyes. High-performance liquid chromatography is a technique not often used during ink analysis and is only used in cases where two inks have very similar colorants and thus need further analysis. It is an extremely sensitive technique that can distinguish the difference between the other components in an ink, including those that are not optically active in the UV-Vis spectrum. HPLC is a form of chromatography in which the analyte is carried through a high-pressure chamber using a carrier gas such as nitrogen. Molecules are separated in this chamber based on how they adhere to the surfaces within the chamber, and the moments at which they stop moving through the column are recorded by a detector. Different inks will separate into their constituent parts inside the chamber such as this, and will produce a unique signature that can be analyzed for specific components. This technique is much more expensive than previous and requires large amounts of expertise in not only the setup but also the analysis, and as such is reserved for the most challenging of cases.
This is a critical evaluation of the methods used in this group project. To be able to perform a critical evaluation of the methods we used, we first need to look into the advantages and disadvantages of direct observation, VSC, and fiber analysis respectively. To start out, I'm going to have a look at the advantages of direct observation. The analysis is very cheap and easy to perform without the need for expensive equipment. It is also very quick, which leads to high cost efficiency with this analysis. It is very easy and simple to compare and contrast several samples with each other. Most importantly, however, this type of analysis is non-destructive and delivers valuable initial information. Direct observation also has its disadvantages. It can be very subjective, as things like the feel and the texture and to some extent the color can be perceived differently by different people. It is also only viable in the observation of very initial information, meaning that no further information on the origin or the producer of that paper can be gained. There's also always the need for one or more comparison samples. Next, I will have a look at the advantages of VSC analysis. VSC can be done very quickly and is very cheap to perform, as it doesn't require any kind of advanced or highly complicated machinery. It is also non-destructive, which allows for further analysis on the same sample. Comparisons between samples is very easy with VSC analysis. A very big advantage of VSC analysis over different analysis methods is the fact that filters can be applied and the imaging quality is very, very good. VSC analysis also has some disadvantages. VSC can be interpreted subjectively, meaning that if two people were to look at a check under a high-pass filter that fluoresces, these results might be interpreted differently. There's also the need for a comparison sample, and it is not possible to always get a clear and decisive result. Now we will look at some of the advantages of fiber analysis. The term fiber analysis includes a wide variety of analysis. For example, fiber microscopy, FTIR analysis, or ICP-MS. These methods all have in common that they are more sophisticated. For example, all these methods require the paper to be in the pulp form. This offers, however, a higher discriminating power, meaning that with some of these analyses, origin and maker of different papers can be determined, as well as other various chemical impurities or chemical processes that can be determined. For example, the mechanism of pulping and impurities like copper that was in the soil that the tree absorbed. There's also no need for a comparison sample, as the spectra of different papers can be compared in a database. Fiber analysis also has some key disadvantages. Arguably the most important one is that it is a destructive technique, as it requires the paper to be transformed back into pulp. There is also the need for a more sophisticated data analysis, especially in cases of FTIR and ICP-MS analysis. The high cost of the sophisticated machines makes the overall analysis more expensive and more time-consuming. In this critical evaluation, I want to talk about two parts. First, why do we use the various methods? And second, what is the cost efficiency and why is it important? First of all, I want to start by pointing out that not a single method we discussed in this presentation is superior to the rest. All of them have pros and cons. For example, only initial information can be gained from an observation, but it is very cheap and quick to do. On the other hand, fiber analysis can give us very accurate and very precise information, however it is destructive in nature. I also want to point out a key distinction between FTIR and ICP-MS analysis. FTIR can give us information on the origin of a paper, but it gives us information with overlapping peaks that can be read within a database. ICP-MS has no overlaps in peaks, but it needs a comparison sample. In the second part, I want to talk about cost efficiency, as it indicates a relationship between the amount of money spent on an analysis and the information gained from it. As an example of high cost efficiency, I will point towards the direct observation, as it is very cheap and very quick to do, but for the amount of money you spend, you receive a lot of information on a sample. This concludes this group presentation. Thank you very much.